Assalamu alaikum. We are Group 3. Our project is an intelligent personal assistive robot for emergency awareness and communication support. The main idea is to build a Bangla interactive home assistant robot that understands simple needs, supports communication, and responds safely inside a domestic environment. We focused on people with hearing or speech impairments. They may need water, medicine, help, or may need to warn others, but family members may not understand the sign immediately. So, instead of a static sign language recognizer, we designed a mobile companion robot that observes the user, interprets basic Bangla signs, gives Bangla voice and text, and can move towards the user. The system has three major functions: sign to voice translation, voice to text display, and autonomous navigation. Together, this makes the robot useful for communication and emergency awareness. For sign to voice, the camera captures the hand gesture, the AI model classifies it, and the robot maps it to a Bangla sentence. The 6 classes we used are food, water, help, fire, sleep, and medicine. For voice to text, speech from a caregiver is captured through the microphone and shown as text, so the hearing impaired user can understand spoken instructions or nearby speech. For navigation, the robot can rotate to search for the user and then move towards them. The mechanism wheelbase supports forward, backward, sideways, and rotational motion. The workflow is input comes from the gesture or speech, the Raspberry Pi processes it, the software decides the meaning, and the robot responds through display, speaker, or movement. For hardware, we used a Raspberry Pi 02W, a 5 megapixel camera, pan tilt servos, ESP32S3 microcontroller, DC motors, L298N motor drivers, a 12-volt battery pack, buck converters, and a custom PCB. For AI, we used a MobileNet V2 and TensorFlow Lite with integer 8 quantization. Now, we will show a live demo of the robot in action. The robot rotates 360 degrees to find the person and then moves towards them. Here, you can see that the robot is rotating 360 degrees to identify the person, and when he locks in, then it moves towards that person immediately. So the robot can successfully track and follow the person to aid him continuously. Now we will see the sign language detection in action. The robot uses its camera to detect a sign language, and then it interprets it and converts it to a Bangla message. Here my friend is showing he needs water, as this is the symbol for water, and it will be updated in the terminal saying that he needs water. So here you can see that the terminal show amar pani dorkar. Now he switched his sign, so it is now showing agun bipod, that is fire, because he is showing a symbol that means fire, which is shown by this sign. The model was trained on 1200 Bangla sign images and compressed to about 610 kilobyte. On the reserve test set, the integer 8 model achieved 100% accuracy, precision recall, and F1 score. The total cost was about 18,000 taka. The impact is independence for the user, less monitoring, stress for caregivers, and affordable assistive robotics for Bangladesh. Future work includes more Bangla signs, a robotic arm, and SLAM-based multi-room navigation. To conclude, this project combines Edge AI, computer vision, NLP, and robotics for safer and more inclusive home communication. Thank you.